Hello, my name is Rex Dyer. I'm the founder and vice president of Ag Defense Systems. Ag Defense Systems is a food safety technology company, and our goal is to bring food safety testing for foodborne illness to food processing plants. Currently, food processors send samples to off-site labs for testing, and this is a cost issue. And also the long turnaround time on results means that food processors often send food to market before test results get back, which means if they find out later that a batch of food was contaminated, they must do a massive recall, which is a huge expense and a problem for their brand, and causes cost repercussions beyond just the recall of the food. So we want to bring food safety testing back in the processing plant so that food processors can be assured that food that goes to market is clean before it goes out the door. What we have here is a prototype to help food processors do that. This is a very simple prototype that we want converted to a commercial product. And what this instrument does, it's called the BioPrep. What it does is it pulls DNA out of food, and any microorganisms such as E. coli or salmonella that may be on the food, it will pull that DNA out of the food as well and purify it. We want to test at the DNA level because that's a very sensitive test. And we can test at the DNA level using a machine such as a real-time PCR instrument shown there. Ultimately, what we would like to do is integrate this BioPrep instrument along with a real-time PCR instrument to create a turnkey product that we call the BioSage. But the limiting factor in DNA testing right now for a food processor is a simple automated sample preparation unit, and that's what we've developed in the BioPrep, and that's what I'm going to show you. So if you come look at the BioPrep, the version we have, it's basically has a front and a back. The front is basically the guts of the instrument. It's got various valves. These are pneumatically driven valves. And it's also got pinch valves that are normally closed, so they can be opened to direct flow in a certain path. And it also has peristaltic pumps to allow pumping of the material through this tubing. So it's pretty simple in mechanics. And I'll go through the process here in a minute. So that's the front side, which is the meat of it. The back side is the wiring of all the pumps and the valves. So this here is a PLC, programmable logic controller, that controls the timing and firing of the valves and the pumps. It's got a motor drive for the motor that runs the grinder, and it's got some extra power supply to take some load off of the PLC. So then if we go back around to the front, the instrument is run, it's semi-automated, and it's run by pushing these buttons, and these buttons activate the program, the ladder logic program in the PLC, to determine the sequence of events that happens. So this BioPrep is basically works in three kind of stages. The first stage is grinding, and in that stage the food sample is put in the grinder, liquid nitrogen is delivered to the grinder to freeze the food to a very hard state, and then that food is pulverized to a powder, a very dry powder. When it's frozen hard in liquid nitrogen, it grinds to a very dry powder. Then a lysate solution, which is a chaotropic salt, is delivered to the grinder and that is moved to a second stage, which is called the lysis stage. In the lysis stage, that ground up material with the lysis solution is passed under high pressure through a small orifice, which puts shear forces on the cell walls of the bacteria and tears them open. That releases the cellular contents, including the DNA, the fats, and the proteins. Then that lysate, that's those cellular contents, are sent to the third stage, which is the DNA purification stage. And that lysate is passed over a DNA resin, basically a DNA binding column, to capture the DNA. And then that bound DNA is washed with various solutions to get rid of the proteins, fats, and carbohydrates. So you're left with clean DNA, which can then be eluted off the column, collected, and analyzed by real-time PCR. So I'm going to show you this thing actually working. I'm going to open the scuba tank here to allow high pressure to be delivered when the valves on the BioPrep are activated. The first step I do is I press this white button, and so I'm starting down here. So if I back up, we're pretending that food has already been ground and mixed with lysis solution and then drained into this tank 1. We don't have this grinding and transfer to tank 1 hooked up. We're working on incorporating a new model of the grinder, and so we don't have that hooked up. But basically, food would be put in here. This valve would be activated to open to send in liquid nitrogen from this tank. That would hard freeze the food. Then this motor would be activated to turn a mortar. So this is basically a mortar pestle that would grind the food, and then a lysis solution would be delivered into the chamber to wash the ground material into this first tank that we call tank 1. From there, we have to move the material from tank 1 to this section of pipe right here, which is the lysis chamber. Okay, and we're going to move that material from that tank to this section of pipe by opening this valve and this valve. And we're going to activate pump 501. So material is going to be pumped up here. This valve will open, allowing the material to enter the bottom of this column of pipe. And when that column of pipe is full, I will know, because it will start bleeding off the top, at the top of the column of pipe, and drain back into this tank 1. Okay, so I'll show you that. Push the white button. Whoops. Did you stop it?